Have you ever wondered how we actually know if a new medicine is the real deal? Or if that health trend all over your social media feed is legit? Well, that's exactly where biostatistics comes in. Think of it like detective work for our health, turning a whole mess of data into clear, life-saving answers.
And, the stakes couldn't be higher. Is a result just a random coincidence, or is there a real, meaningful connection? Getting this right can literally change millions of lives. So today, we're going to open up the statistical toolkit that helps scientists find out the truth.
So here's our game plan. We'll start with the big picture. Then we'll get our hands on two really powerful tools: Chi-square, which is great for sorting things out, and regression, which is all about predicting. We're also going to tackle the messy reality of data before we put it all together in a real-world example. Sound good? Let's go.
Okay, so let's start with the basics. At its absolute core, biostatistics is just about using the power of data to unlock the biggest mysteries of human health.
And this is so important. These aren't just some abstract equations floating around in a textbook. No, these are the very tools that build the foundation of modern medicine. They let us move past guesswork and hunches and into a world of confident, data-driven decisions.
All right, let's grab our first tool from the kit. This is the chi-square test, and I want you to think of it as your sorter tool. It's perfect for when you've got data you need to organize into different groups and you want to see if anything surprising stands out.
So what does that really mean in plain English? Well, Chi-square helps us look at categories, things you can count and put into neat little groups, and ask a simple question. Are these two things related? Is there a real link between them, or is what we're seeing just random chance?
Imagine this. You're sorting patients into two buckets: smokers and non-smokers. Then you sort them again into has lung disease and no lung disease buckets. The chi-square test is what tells you if that has lung disease bucket has way more smokers in it than you'd expect if smoking had no effect at all. It spots the imbalance for us.
And you can see right here when it's perfect to use. If your data can be split into clear categories, like smoker versus non-smoker, or vaccinated versus not vaccinated, chi-square is your go-to for answering these powerful yes or no type questions between different groups. Okay, time to grab our second tool. This one is regression analysis, and we're going to call it our predictor tool. See, this tool is less about sorting and more about finding trends, spotting patterns, and figuring out the strength of different relationships.
Now, I know that sounds a little technical, but the idea is actually super simple. We're just trying to figure out how one thing changes when another thing changes. It's kind of like a seesaw. If one side goes up, what happens to the other? It's all about finding those connections so we can make predictions.
And regression basically comes in two main flavors. You've got simple regression, which is a straight one-on-one comparison. But we all know real life is way more complicated than that, right? And that's where multiple regression just shines. It lets us look at a whole cocktail of factors, like exercise, diet, and age, to see how they all work together to affect something like blood pressure.
This brings us to a super important step in any kind of analysis: the reality check. Because let's be honest, in the real world, data is messy, it's complicated, and we have to be really careful not to get tricked by factors that might be hiding in plain sight.
And this question is absolutely crucial. Just because two things seem connected, it doesn't automatically mean one causes the other. There could be a third, hidden factor that's secretly pulling all the strings. And this brings us to two really important ideas: confounding and effect modification.
Okay, getting this distinction right is everything. It can be the difference between a flawed study that gets pulled and a groundbreaking one that changes medicine. A confounder is like a magician's trick. It creates a fake link that we need to expose and get rid of. But an effect modifier, that's actually part of the real story. It's a factor that genuinely changes the relationship, telling us that the effect isn't the same for everyone.
These examples make it crystal clear. In the coffee scenario, it turns out it was the smoking all along, creating a misleading link with heart disease. That's confounding. But in the drug scenario, gender is an effect modifier. It's a real biological finding that tells us the drug works differently in men and women, and that is incredibly important to know.
All right, enough theory. Let's get our hands dirty and see how a researcher would actually use regression to get a clear, solid answer from their data.
Okay, we have our mission. The thing we're investigating is weekly exercise, and the outcome we're measuring is blood pressure. Nice and simple. Let's walk through it.
So first things first, you gather your data on a bunch of people. Then you plot all that data on a graph, where each person is just a single dot.
Now for the cool part. The computer draws one single line that best slices through the center of that cloud of dots. That line shows us the overall trend.
That best fit line isn't just a random line. It has a specific mathematical equation, and that's what we calculate next. Don't worry about the math itself, though. This equation is just the key that lets us get to the final and most important step, figuring out what it all means in the real world.
And boom! Here's the payoff. The regression analysis gives us a powerful, specific statement just like this. It actually quantifies the relationship, turning that messy cloud of data points into a clear, actionable insight. Pretty cool, right?
But hold on, remember our reality check? A really sharp researcher would immediately ask this. We all know that age can affect both how much people exercise and their blood pressure, so age could totally be a confounder here. Our next step would be to use multiple regression to account for age so we can find the true effect of exercise all by itself.
So let's zoom out. Why does all this matter? It matters because these tools let us move beyond "these two things seem related" to actually understanding what's causing what. They are the engine behind evidence-based medicine, they shape huge public health policies, and honestly, they even help you understand that next big health headline you see online. It's about seeing what's really going on behind the numbers.
And that's the real power here. Biostatistics gives you a framework for asking and answering really important questions about the world around you and about your own health. So, think about it. What connection would you want to investigate first? If this explainer helped you get a handle on these concepts, definitely make sure to like, comment, and subscribe. We always love hearing your feedback and your ideas for what you want to learn about next. Thanks for tuning in.